iPad calculator. Let's get into it. Hi, I'm Sarah. I've been a science and math teacher for 20 years. I like to make math fun, engaging, and not so scary for everybody. If you want more practice problems, more information, tutoring sessions, click the link and do the stuff. So there's apparently a new iPad calculator. That's all the rage. A lot of buzz about it. I have not used it at all because I just wanted to use it here and get my honest opinion on how I feel about it. Is it just the regular calculator app?
There's never been a calculator.
All right, let's see. So apparently is you can just write 2 + 3 equals, and then it pops up. Oh, it's mocking my handwriting. Ah! Okay, so 149.3 minus 274.6 equals, stop it.
It does slope too.
Stop. Wait, so if I do,
I'm not sure, but I just know that like if you do an equation with a y in it.
what does that mean? Yeah, 4 = 4, 3 = 3. Yep. Okay, a right graph. Wait, what are you doing? Okay, so 3x + 4, that's going to be about there. You can't move side to side. You can only go up and down. So if I do that and that, so what would be interesting is if it can, there's insert results and suggest results. So y equals 3x + 4. So let's see. Dismiss error. Okay, let me see if I erase all of that. I like that it does just the calculations. That's pretty sweet. There's a ruler. Okay. Wait, where'd you go? It go. This is just beta. Beta. Okay, you didn't like that ruler. I'm sorry. I'm sorry. Come back. Oh, I broke you. I'm so sorry. Let's try relaunching it. Oh God, what did I do? There we go. Okay. Okay, so that's causing problems. I was just trying to use the ruler. The ruler is messing it up. Let's see. It's the opacity. All right. So then I wonder if you can do like slope equals. Oh, you can copy that whole. That's pretty cool. Straighten. Okay. I can duplicate. Oh, that's fun. Those two. I don't know what those little guys are. Listed title, slope. Okay. So this seems like it's probably really good for taking notes. All right. So to insert a graph. All right. When you write down a function, you'll be able to insert a graph. I'm just going to write in, maybe I should have played around with this before we started, but okay. So if you do just the y equal, then you're supposed to be able to just, so y equals 3x + 2. Let's see. Okay, I read it. So y equals 3x + 2, insert graph. Oh, there we go. So then I can zoom in. All right, and then I can recenter it. I bet I can change the settings for like the centering or whatever. Okay. Ooh, you can really distort that. All right. Can you change the type of graph? Oh, okay. And then you can, that's pretty cool that it'll like copy and paste it right there, that it sort of recognizes it. But I think what I should be able to do, there we go. Okay. So if I just click on one of the numbers, oh, that's neat. What you could do, let's see. Okay. So we've got 3x + 6. So if I duplicate this and then move, what have I done? Okay, I'm not going to duplicate it. Change my mind. Okay, but what if I put in another one of y equals 3x - 2? I wonder if that would, okay, so you can either get it on a separate graph or you can add it to the existing graph. Oh wait, why did it do -2 - 6? Weird. All right, let's see what it does. Oh, I put it in a new graph, didn't I? I didn't want to do that. Okay, delete. Okay, so this one, okay, add to existing graph. There we go. Okay, so now I wrote them so they have the same slope, so they're parallel. Because what I'm thinking is what you could do with this is you could do where you're just investigating, how does the changing of the y-intercept affect where the graph is. So what you could do is if you have this 3x - 2, right, you just push on the 2 and you can change it around and you can see how it kind of slides along the x-axis and you can move it all the way back here, right? And it makes it -9. Okay. All right. So -9, which is +9, right? So we can, no, so if it's -6, that does kind of show you that like -6 is the same as +6. That's cool. Okay, so then I'm going to move this down here so it's at like +1. Sure. Actually, you know what? I'm going to move it back to this. Whatever. We'll leave it there. Sure. So now I want to play with the slope. I wonder if the slope will change in the same way. Okay. So now I can increase it. All right. You can see how it increases all the way, but how it's not going to go beyond vertical. That's a pretty cool thing to see with it. It's a nice thing with this like slider bar, that it's getting more and more vertical, right? Not almost, you could use that as like introducing like a limit sort of thing. But I can make this as big as I want to, right? I can get this all the way up, but it's never going to be perfectly vertical. I'm just going to scroll way back down. Okay. All right. So now I went into the negative. 2, 1, 0 is a horizontal line. Great. And then you go into the negative slope, kind of seeing how these are almost parallel, right? And this could even be, these are almost perpendicular, but not quite. So a lot of times like students will forget that like a perpendicular slope is both opposite and reciprocal. So in this case, we've got 3x, which is a slope of positive 3. And then this one, we've got a slope of negative 3. And you can see they're not perpendicular, right? They're crossing each other. Certainly they are crossing each other, right? But they're not fully perpendicular. So it's not just opposite.
What's your initial reaction to this?
Some really cool features. Honestly, I'm not a huge fan of like, I'm just holding my cup. Not a huge fan of, I guess I'm struggling to think about like when you would use this, honestly. Like unless you were like at a workshop, at a conference or something like that, and you don't want to have to deal with notebooks and all of that. Right now it's in beta form, so it is a little bit finicky. I wish the ruler weren't having it freak out, because I'd like to try that, because I wonder if the ruler, you could use that to measure the angles, like if there's more protractors or anything like that. It's very similar to Desmos. So this is kind of what I was just playing around with, was sort of an activity that I would do with my students with Desmos, where it's like, just change around the B value and see what happens to the graph. Change around the slope, see what happens to the graph. This with the little like slider bars, I think a really nice demonstration of how changing the slope and changing the y-intercept does affect the line. So I think that could be really useful. Oh, that's nice that it's like transparent. I haven't used Desmos on an iPad, but really it's mainly like typing stuff in. Photomath is just going to give you like an answer, like, you know, a solution, but it'll just sort of write out the steps for you. This is, I would say, just in my limited exploration, I like that it does the arithmetic piece for you, because I think that is sometimes really important for students, especially in their notes and their initial understanding, right? If they're trying to write down, let me see if it does it do trig ratio? Let's see, sine of 60. Ooh, okay, but I wonder if you could get it in, I would have to double check it, because negative 0.30481, that's gonna be in radians. I wonder if you could, yeah, I would be curious to see sine -1 of 5/3. Oh yeah, of course it's not real, because I'm not thinking, but the reason it gave me an error was because sine is the opposite of the hypotenuse, and I had the hypotenuse as 3 and the opposite as 5. That's impossible. So I'm going to flip that to 3/5. 3/5. So sine -1 of 3/5. Let's see. Yeah, so it's definitely in radians. And the reason I know that is because the inverse sine of that opposite over hypotenuse, that should be giving me the angle measurement. An angle measurement of 0.6435. That's not going to be a degree measurement, right? A degree measurement is going to be, you know, a bigger number. The radians will be between 0 and 1, I think. So I'm sure there's like a setting or something that you can change it into radians and degrees, but I just haven't messed around with that. So overall, I would say it's okay. I'll be curious to see what people come up with for applications, like in their classroom or whatever. But I think generally, like, the iPad has been missing a calculator, right? Like you have to get your phone out or your calculator to get that out. I do like that it solves it for you. it just does the calculation, so you don't have to use like type in a separate calculator. You can just write it out, because again, the arithmetic part, that's not really like the point of a lot of math problems, especially when you get into the upper pieces, which is why you always have a calculator, is to do the arithmetic part.
What do you say to people that think this is another nail in the coffin towards students learning, or laziness, or this is just another cheat?
Here's my question: is that like what I just did with that sine -1 is 3/5, and I go, ooh, that's radians, that's not degrees. That to me, as a teacher and as a thinker here, shows that I understand more of this than just great, it equals 0.6435. So for me, the calculation there, like when you get into upper level of maths, I don't think it's as in the arithmetic piece is not as essential as understanding the topic itself, and understanding that, like, if I'm trying to find degrees, that answer right there doesn't make sense. Okay, like if I'm doing inverse trig and things like that, that answer doesn't make sense because it's not going to be in degrees. So I would say this is, I mean, it's a tool. It's just a tool. It's just doing the calculation for you. It's not answering the question for you. Because if you think about the part with the two line graphs, if we ignore the trig stuff, we just look at the y equals 3x plus 6 and y equals -3x minus 1. What I would be asking my students to talk about is how does increasing the y-intercept change the appearance of the graph? How does decreasing the slope change the appearance of the graph? That's not something you can get from photomath. That is taking different things and putting them together and really sort of like puzzling through this. So if the question were just graph y equals 3x plus 6, done. Graph y equals -3x minus 1. Great, done. It's done for you. But I don't think the problem is with the tool. I think the problem is with the question that's being asked.